Today is the last day of the Chapter 6 review, so we're going to start with problem number 93. Find the exact value of each expression, give the answer in radians. So arctangent just means tangent to the negative 1. Where does tangent equal 1? No. Tangent equals 1 when sine over cosine equals 1. So sine and cosine would have to be the same thing. Where are sine and cosine equal? At 45 degrees in radians, that would be pi fourths. Okay? So you're just going to reason through those. Those are pretty quick. Same with the next group. So look at number 101. When is the arc cotangent equal to root 3 over 3? Well, what values for sine and cosine would give us root 3 over 3? So basically we're doing the cotangent inverse is equal to root 3 over 3. Now, what's another way to write root 3 over 3? It would be 1 over root 3. Okay? Now, that comes from 1/2 divided by root 3 over 2. So where do we get that for the cotangent? Well, cotangent is cosine over sine. So where is cosine equal to 1/2 and sine is equal to root 3 over 2? That would be pi thirds. Okay, so you just kind of use the unit circle and figure out what you want. And I believe, I don't believe. I'm looking. I want to make sure they don't do something silly in the answers. Okay, review exercises. What number was that? 101? 6. Oh, that was in degrees, so 60 degrees. Okay, we're good. So the next one, you're just going to use your calculator to figure out the answer. And then we're skipping to 125. All right, number 125 says the sine of 2 theta is equal to negative root 3 over 2. And we want to get answers between 0 and 2 pi, and they're both equal to, so we get brackets on both sides. Oh. Great. So, where is the sine equal to negative root 3 over 2? Which two quadrants? Would be 3 and 4. All right. So, what is that angle there? Just pull it right off your unit circle. So this would be negative root 3, and this would be negative 2. What did you say the angle was? It's got to be in radians. 5 pi, no, it's not 5 pi over 4. 4 pi over 3. Okay. So the sine of 2 theta is negative root 3 over 2. So the angle that creates that is 4 pi over 3. So I now know that 4 pi over 3 is equal to 2 theta. So what would theta be equal to? Two pi over 3. Does everybody see that? So 2 theta is 4 pi over 3. So if I divide by 2, that cuts this 4 in half. So theta is equal to 2 pi over 3. Does that angle fit in the window? Yes. So we're okay. All right, let's do the next angle. How big is this one? Look at your unit circle. Which angle in quadrant 4 gives a sine value of negative root 3 over 2? And we need to do it in radians. So 5 pi over 3. Now what? Well, that is equal to 2 theta. So I divide by 2. How do you divide a fraction by 2 if the top is odd? You double the bottom. So you can either cut the top in half, or you can multiply the bottom by 2, which is what we'll do, and I get 5 pi over 6. Is 5 pi over 6 inside the window? Yes. Do I need to look any further? Are there other angles that create negative root 3 over 2 that I can cut in half and still land between 0 and 2 pi? And the answer is yes. Because if I do this, I go all the way around, and then I go to here. So that's basically, we're doing it thirds. So 3/3, 6/3, 9/3, 10/3. So 10 pi over 3 is equal to 2 theta. Divide by 2, and I get 5 pi over 3. Is 5 pi over 3 inside one full rotation? Did I do that right? 3, 6, 9, 10. Yeah. Is 5 pi over 3 inside one rotation? Yes. Okay. So let's look again at a different angle. So I'm going to count my thirds. 3/3, 6/3, 9/3. How far is it to there? It's not quite 12, right? 12 would be 2 full rotations. So if I didn't quite make it to 12/3, what did I make it to? 11/3. So 11 pi over 3 is equal to 2 theta. Now I divide by 2. How do I cut a fraction in half? Times the bottom by 2. So I get 11 pi over 6. Is that inside one rotation? Yes. Now I need to keep doing this until I find one that doesn't work. Okay. So count this out with me. 3/3, 6, 9, 12, 15, 16. 16 pi over 3 is equal to 2 theta. Divide by 2, and I get 8 pi over 3. Is 8 pi over 3 inside one rotation? No. One rotation would be 6/3. So this one gets broken, and these are our answers. Now, as a general rule, If you are dividing your angle by 2 or some other number, you're going to have to do multiple rotations. So whenever it says the cosine of 2 theta, or 3 theta, or 4 theta, you're going to have to do multiple rotations. If it's the opposite and it says the sine of theta over 2, then you're actually going to have fewer answers. So before I erase this, does anybody have any questions on how I got that? Okay, so let's do this. The sine of theta over 2 is equal to negative 1/2. And I want answers that are between 0 and 2 pi. Okay. Which quadrant is the sine equal to negative 1/2? Oh, we don't want to do the sine. We want to do the cosine. I didn't think far enough ahead. Which two quadrants does that work in? 2 and 3. Okay. This angle is going to be 2 pi over 3. And this angle is going to be 4 pi over 3. Anybody not understand that? Everybody's good? Okay. So 2 pi over 3 equals theta over 2. So I just times by 2, and I get 4 pi over 3. Is that in the window? Yes. Okay. Do the same thing with the next one. Times by 2, and I get 8 pi over 3. 8 pi over 3 is not in the window, so it turns out that's the only answer. So in this problem, we had two angles that were in a full rotation, but when I multiplied them by 2, one of them got too big. In the last problem, I had 4 angles. 2 of them were bigger than one rotation, but when I divided them by 2, they did land inside one rotation. So if you're dividing the answer, you're going to have extra answers, extra angles. If you're multiplying the answer, then you're going to have fewer. And I ended up changing my mind on the sign because of this. If I did the sine of theta over 2 equals negative 1/2 from 0 to 2 pi, I'm looking in quadrants 3 and 4. So this is going to be 7 pi over 6. And this one is going to be 11 pi over 6. Anybody see a problem? When you double those, what happens? They're both too big. So what values of theta satisfy the sine of theta over 2 is equal to negative 1/2 on the domain 0 to 2 pi? None of them. It never happens. Okay. All right, that will take you through that first one. Look at 131. 131 says 4 cosine of 2 theta plus 2 is equal to 0, and we're still going from 0 to 2 pi. So all you have to do is subtract the 2 and divide the 4, and then it's just like the problem above it. In fact, we just did that one. So take a look at 137. The tangent of 2 theta is equal to negative 0.3459. So the tangent is only negative when the sine and the cosine have different signs. If they're both positive, then the tangent is positive. If they're both negative, then the tangent is positive. So we're in either quadrants 2 or 4. Okay? Well, luckily, it wants our answers in degrees. So we can just use our calculators to do the inverse. If I take the inverse tangent of negative 0.3459, I get the answer negative 19.08. So this angle right here is negative 19.08. If I set that equal to 2 theta and divide it by 2, I'm going to get negative 9.5. Is that in the window we want? No. So how do we figure out angles that are inside the window we want? Well, it's very simple to create this angle. How do I do that? I could just take this number and add 360. That's a good way to do it. Not 36. So 340.9. What do I do with 340.9? Divide it by 2. So I divide by 2, and I get 170.46. Is that in the window? Yes. Are there any others that I can divide by 2 and still land in the window? Well, let's look at this angle. Where does that angle come from? (180 minus 19.1). So 180 minus 19.1. Now what do I do with that? Divide it by 2, and I get 80.46. Is that in the window? Yes. Will there be any more? Well, I'm making my resulting angles smaller. So I might need to look at multiple rotations and see if I can divide those by 2 and they still land inside the circle. So for the first one, let's get rid of these. How do I get that angle? There are lots of ways to do it. 360 plus 180 minus 19.1. That would work. What's another way to do it? (160.9) plus 360. That would also work. Okay, so I would probably do 360 plus 180 minus 19.1. Is that what it was? Okay, now I get 520.9. Divide that by 2. And I get 260.45. Does that work? Yes. Okay, now let's check this one. How would you do that? Well, you could take the 340 or whatever it was and add 360. I'm just going to do 720 minus 19.1. So 720 minus 19.1. Divide that by 2. And I get 350.45. Should I stop there or should I keep going? Stop. Why? The next angle is going to be 2 full rotations and almost half of a rotation. And once you do 2 full rotations, when you divide by 2, you're going to get something bigger than 360. So at that point, you might as well just stop. Okay. These are problems in your set, by the way. I guess I should have told you that. I've been doing the odds. I know I don't normally do that. So 139. This is in your set. 4 cosine squared of theta plus 3 cosine of theta is equal to 0. What should I do? Take out a cosine. So the cosine of theta is equal to 0, and 4 cosine of theta plus 3 is equal to 0. So I get the cosine of theta equals -3/4. So now I just need to determine what angle makes the cosine of theta equal to 0. It happens twice at 90 and 180, and it wants the answers in degrees, or 90 and 270. And then for the other one, we need to do the inverse cosine. So the inverse cosine of -3/4, and I get 138. So this is 138. Are there any other angles in one rotation that will give us -3/4? Well, there's going to be one here. How do I figure out what that angle is? Well, I would just do 180 minus 138.59. And then whatever that answer is, I'm just going to add it to 180. And that would be the angle. Okay? Same basic thing until the end. All right. Get to work.